Hi everyone, so in this video I'm going to explain to you how to solve this exercise 6. So you have a rectangular loop, okay, so the rectangular loop is blue color as in the figure. So it is situated in the xy plane, okay, so you can see the xy plane and move away from the origin at the velocity of this. Okay, so this loop is moving. You move the loop as a whole. Again, not sliding bar. You move the whole loop, okay? Okay, at the velocity, which is 5 in the y directions. And the magnetic field is given by this, right? So if the R is equals to 5 ohm, okay, where is the R? Okay, so R is over here. Determine the current in the loop. So the loop resistance might be in north. The loop resistance is the internal resistance of the wire. Okay, so we don't consider the internal resistance of the wire in these questions. Okay, so the first step would be identify whether it is motional, okay, motional EMF or transformer EMF, right? So remember I told you motional is when you have something moving, okay, when you have a conductor moving. And for the transformer EMF, okay, we are going to see whether your magnetic flux density has variable T. So in this case, question already give you this one, right? So it means that you are going to calculate this motional EMF. Okay, since this is a loop, so we will have 4 sections of wire, right? So from 1 to 2 is one sections, and from 2 to 3 is another section, and 3 to 4 another sections, and 4 to 1 another section. So you have section 1, section 2, section 3, and section 4. Okay, you have 4 sections of wires that move together. Okay, so to calculate the motional EMF, we have to calculate the voltage generated at each sections one by one. Okay, meaning that for section number 1, you are going to calculate the voltage. Section number 2, you are going to calculate the motional EMF. And section number 3, another motional EMF. Section number 4, another motional EMF. We calculate one by one and then we add up together to find the total motional EMF before we find the current. Okay, so this is basically the approach to solve these problems. Alright, so now let's look at sections of 1 to 2. Okay, we go to 1 to 2. Now we refer to section 1 to 2. Okay, this wire. Okay, so I will say that this is side 1 to 2. Okay, so for motional EMF, we are going to use this formula. Okay, integrate U cross B dot dl. Okay, so what is our u has been given by the question, so we can directly apply it. So it's 5 in the y direction. And how about our b also being given by the questions, is 0.2 exponent negative 0.1 y, right, and in the z directions. Okay, dot product dl. So L is the length of side 1 to 2. Okay, if you want to know the length of side 1 and side 2, you will refer to as the x, right? Okay, so over here it will be dx. Okay, and the unit vector is x. Alright, so now let's determine the interval of our integrations. Okay, so for this, we need to identify the direction of the current flow. Okay, so how the current will flow in this loop. Okay, let's look at the directions of our magnetic field. So according to the questions, our magnetic field is going up. Okay, going up. Okay, so it means that the current that is generated in the loop will generate another current. Okay, another current that is in the current that is generated in the loop will generate another magnetic field which is opposed to the directions of the original magnetic field. Okay, so it's going to generate a magnetic field which is in the negative z direction. So your four fingers, okay, will be gripping, okay, the wire 1 to 2 this way. Okay, grip like this. Okay, then only you will go down. Okay, so if your forefinger gripping like this, okay, your thumb will be showing these directions. Okay, so these directions would be the direction of your current flow. So your current is flowing, okay, from 2 to 1, right? So from 2 to 1. So 2 is at the position, because here it mentioned the length is 2 meter. So over here will be 1 meter and another side will be -1, okay, to be 2 meters. So we will integrate from 1 to -1, okay. So integrate from 1 to -1, okay, -1. Right, so now let's simplify the cross product, okay, for y and z. So y cross product with the z, you will have x, right? Y, z, x, right? Meaning this is going to be x, and x dot product with the x dot product with the x is going to be 1. It's going to be 1. Okay, so let us rewrite our integration. So it will be 1, -1. So it will be 1, okay, when you multiply exponent -0.1 y, okay, dx. Okay, so there is no more unit vector. Okay, no more unit vectors. Okay, so let's do the integrations. Okay, so since we integrate with respect to the x, so the answer will be e1 exponent -0.1 y. Okay, so now we will have x, right? Because you integrate with respect to the x, so it's -1 and 1. Okay, so you have 1 exponent -0.1 y, and then you have -1 minus 1, so you have -2. Okay, so you have -2, so it means that -2 exponent minus 0.1 y. Okay, so now your equation has a variable y. Okay, so this y is actually representing the positions of wire 1 to 2. Okay, so the wire 1 to 2 is at the positions of 2 meter. Okay, so you can replace it, okay, with 2. Okay, you can replace the y with 2, so it's -2 exponent -0.1 2, okay, and equals to -1.64 volt. Okay, so this is the motional EMF generated at side 1 to 2. Okay, so now we move on to the second side. Okay, the second side is 2 to 3. Okay, 2 to 3, yeah. So we go to side 2 to 3. Okay, so it is side 2 to side 3. Okay, we will still using the same formula because we know it is motional EMF generated. Okay, so for motional EMF generated, we use this formula, right? U cross B dot DL. Okay, so what is our U? Same thing, right? Our U is the same thing, right? Our U is 5y, right? Just like for the side 1, 2. And our B is also the same, 0.2 exponent -0.1 y in the z direction. And for the DL is the length of side 2, 3. Side 2, 3, 2 to 3. If you want to know the length, you will look at axis Y. Okay, you will look at axis Y. So this is dy and y. Okay, dy and y. So over here, if you follow this diagram, okay, the current will flow in the clockwise directions. Okay, so your y will be from, okay, 2.5 to 2. Okay, 2.5 to 2, right? Okay, so let's simplify our cross product for the unit vector. So this we get x. Okay, so the x is going to dot product with the y. Okay, remember when you have dot product two unit vectors that is in the different directions, you will get 0. Okay, just now it's 1 because they are in the same directions. Okay, same directions. Okay, but different direction you will get 0. So meaning that for the side 2, 3, your VM motional EMF is equals to 0. Motional EMF is equals to 0. Okay, so this is for side 2, 3. Next, we are going to look at the side 3, 4, right? Side 3, 4. Okay, side 3, 4. So for side 3, 4, okay, we will do the things, okay, just like we do for the side 1, 2. Okay, so for motional EMF is equals to integrate U cross B right DL. Okay, you can basically copy back, okay, copy back the U and also the B. So it is 5y cross 0.2 exponent negative 0.1y, okay, in the z direction. Dot product with the dx. Okay, same like side 1, 2. And for the interval, okay, look at how the current flow. Okay, current flow from 4 to 3, right? It's from negative 1 to 1. So you put it from negative 1 to 1. Okay, so basically you will get the same thing like what happens, okay, for side 1 and 2. Okay, you will get it 2 exponents negative 0.1 y. Okay, right, and this y, okay, is the position of side 3, 4. Okay, let's look at the positions of a side 3, 4. So this is your side 3, 4. Right, it is located at the position y equals to 2.5. Okay, y equals to 2.5. So you could replace it with 2.5. Okay, so when you put it with 2.5, you get a value which is equals to 1.56. Okay, 1.56 volt. So this is the motional EMF. Okay, motional EMF. Okay, for side 3 and 4. Okay, and for side, last one, right? Side 4 to 1. Okay, so this, the condition of side 4 to 1, okay, is very similar like the condition for 2 and 3, right? Because why? Because the length, okay, the length is in the dy, the y direction, so eventually it will lead to 0. Okay, so we just write down here for side, okay, 4 to 1. Okay, the motional EMF is equals to 0. Okay, it's equals to 0. So now we have to sum them up. Okay, we have to add them together. Right, remember what we have? We have this. Right, so we have to add them together. So our total motional EMF will be minus 1.64 plus 1.56, which is equals to negative 0.08 volt. Okay, and for the current flowing in the wire, okay, in the loop, it is going to be total motional EMF divided with the R. So the R is given by the questions, right? So it's equals to 5, so you will have negative 0.016 ampere. Alright, so this is how you determine the currents and also the voltage in a moving loop.